feel they are comfortable with the community. And they often say, we are comfortable, therefore we want to stand. But it's not. People use our hands to monitor performance and ensure that it's done. And why did it make me do that?
Hi, David.
Good day, Prof. It's Kahiso. I'll be assisting you today.
Oh, Kahiso. Okay, okay. Yeah, okay. Welcome, Kahiso. Thanks. Yeah, I think you know what you have to do.
Yes.
Yeah. Last week, David took all the mics off, and he said that they had the option of putting the mic on when they wanted to speak, but just control that. Sometimes some people have their mics on, and some other external noise comes in. So if you can just control the noise that is coming from outside. I'm sure you know how to do that.
Prof. Just try to unmute yourself. I made you co-host. I think you should be able to.
Okay, I have unmuted myself.
Okay.
Okay. I think we can start now. It's 12 seconds past 5 o'clock. I want to be as punctual as possible. Good evening, everyone. Welcome once again to this program where we are providing training, the Siyanqoba program for training students in high school. who are either in the junior phase or in the senior. And the senior phase will be running on Mondays. Well, let me just wait for the others to come in. Okay, I repeat, welcome to the second class, the second session. We started last week with session 1, and all the sessions are numbered from 1 to 9. There will be 9 sessions altogether. And today we launch into session 2. So without much further ado, I want to go straight into the problems. But I would like to repeat once again that you have to do an assignment for each session, and the submission of the assignments, I think by now you have some idea because you have submitted one assignment, but continue to submit your assignments from week to week, and the coordinators will communicate with you regarding that. I presume that all of you have the workbook. The workbook is called a problem book, and it's got problems which are in the junior and the senior problems. The senior problems start from page 26 onwards. And so each session has got a number of problems, anything from 10 to 15, I think. But we will only do very selected problems. Only very selected problems. I'm repeating all this just in case there are some people who did not pitch last week. So there is an item somewhere which speaks about the syllabus, and in that syllabus you will see the problems that we will actually tackle in each session. We don't tackle all the problems which are allocated in that session in the problem book. We only tackle certain selected ones, but you are quite free to tackle the other ones. And if you do that and you want to have some kind of a clarification, you can always send me an email or send an email to your coordinator. Okay, so there are still some people who are coming in. I think we'll just wait for maybe a minute or two. I'd like to start exactly at 5 o'clock each time. So please try to be on time. The coordinator will need a little bit of time, I guess, to admit you into the class. I'm not sure how it works. So we will allow maybe 1 or 2 minutes for that to happen. Okay, I'm going to close the video and go into all right. So let's get into the very first problem. Now, I presume that all of you have seen these problems and have tried them. It is a precondition to be in this program to try the problems before coming into the class. The last thing you do in mathematics is to get the answer even before you know what the question is. Or to get the answer even before you have understood the question or read the question. That is not how we do mathematics. You have to try it out, and then you would appreciate the solution, or you can check to see whether the solution is similar to the one that I'm going to give. And if it is different, if you got a new solution, you can send it to me, and then I will include that as the additional solution in my notes. Okay. Sometimes there are alternate solutions, and I will discuss the alternate solutions whenever that arises. Okay, so we go into the first problem. The question is, how many odd positive integers the sum of whose digits is 4 and none of whose digits is 0 are not prime. Now that's quite a mouthful. So let's first look at the odd positive integers, the sum of whose digits is 4. So I'm going to write down all the integers whose the sum of the digits should be 4. Right? First, I'm going to write down all the positive integers whose digit sum, we'll call it digit sum, is 4. So you have 4, that's one digit, that's allowed, and the digit sum is 4, obviously. And if you got 2 digits, you can have the integer could be 1, 3, or it could 3, 1 is also allowed, or you could have 2, 2. So there are 3 ways in which you can, remember, none of the digits are 0. So you're not allowing, for instance, 1, 0, 3. Otherwise, there'll be infinitely many. And you can have any number of zeros everywhere, and that will make it an unsolvable problem. Okay, so here, you've got, these are the 2-digit ones. For 3 digits, so 3 digits adding up to 4, you'll have to have one of them being equal to 2, and the other 2 will be 1. That's the only way you can get 3 positive integers adding up to 4, 2 plus 1 plus 1. But the 2 could be either in the first position, or the second position, or the third position. All right, so these are the 3-digit numbers which add up to 4. And then let's do the next one. The 4-digit numbers, there's only 1. So you notice we're doing this systematically. We are saying we're not going to just randomly look at digits which numbers whose sum is 4. I'm eliminating every one of them. I start with 1 digit, 2 digits, 3 digits, 4 digits. This way, I'm not missing out anything. It's impossible to have a 5-digit number whose sum is 4 because you're not allowed to include 0. If you include 0, you can still have 5-digit numbers. All right, so this exhausts all those positive integers whose digit sum is 4, but they are odd. So you'll have to eliminate this one, and you'll have to eliminate this one as well, because these are even. So, and even 4. All right, so now you've got only the odd ones, which sum to 4. Okay, so we got the odd, they're positive, they're integers, the sum is 4. None of these digits are 4, but they are not prime. Right. In other words, these numbers are composite. They factorize. Right. Now, so you'll have to take out all the prime numbers. Right. 13 is a prime number. 31 is also a prime number. I'm sure you know that. 11 is not a prime, so we can tick that off. This one here is a question mark because it's a rather large number. And this one, you can see 11 goes into this. So this is 11 times 101. Right? That's easy enough to see. So, so this is also allowed. So the only question mark is 211. Now, how do you know whether it's a prime or not? There's a way to check to see whether a number is prime is that you try all the prime numbers and see whether they factorize. Try only the prime numbers and see whether they go exactly into 11. All right, now obviously 2 is eliminated. 3, this is not a multiple of 3 because the sum of the digits is 4. That's out. 5 is certainly out because it doesn't end in 0 or 5. 7, when you try 7 out, you'll see 7 goes into 30, but there's a remainder of 1, so that is eliminated. And 11, you can try 11, it is eliminated. The next one is 13, and that requires a little bit of long division. And 13 is also eliminated. But you don't have to go beyond 13. The reason being, the next one is 17, you see. And then if you divide this by 17, you're going to get a number which is smaller than 17. So in other words, we already tried all those numbers out. So there's no need to try 17 because the other, if it goes in exactly, then the other factor will be smaller than 17 and That's not true. Okay. So it means that this is a prime. Nothing goes into it. So we have to take this out. So there are only two. And the question is how many? And the answer is two. Because we see that there are only two numbers which fit the bill. 121 and 1111. So the moral of the story is you go systematically, don't read the whole thing. You got odd and positive and four and zero. It's too complicated. So you do it systematically and then eliminate. You see how I eliminate the even numbers. So eventually you come to your answer. Okay, let's get on to the next problem. The next problem is how many factors does this number have? Now, there's a lot to be said about this. The number of factors. How many factors does a number have? So that's the question. Okay, I don't know whether you have my book, but I deal with this quite thoroughly. And eventually we come up with something. I'm going to just briefly go over this. Take, for instance, suppose I take 12. What are the factors of 12? It's 1, 2, 3, 4, 6, 12. And the number is equal to 6. Right. Now, the way to actually find the factors is to factorize it into product of powers of prime numbers. And then this is 2 squared times 3, 4 times 3. So this is how you factorize this. You group together all the 2s and 3s, and those are the only ones. And then you say, okay, is there any way of working out the factors by looking at this? Well, you can. You can work out all the factors starting like this. You can have 1, and then you take all the powers of 2. Because all these are factors. 1, 2, 2 squared. And then you say, after that, now you take 3, and you multiply 1 times 3, 2 times 3, 2 squared times 3. And that's it. See? So, and that gives you the 6. If you work all these things out, you'll get these 6. But if you had 3 squared, for instance, right, then you'll also have 1 times 3 squared, 2 times 3 squared, and 3 times 3 squared. So because then you take 3 squared, multiplying by this. In this case, you will have 9 factors. So is there a way of actually working this thing out? You will see that these 6 factors in this case here is two groups of 3. So here this is equal to 2 times 3. In the case of 9, there are 3 groups of 3. These are all the factors. So in this case here, the number of factors is 3 times 3. Okay? And the way to actually obtain this 2 times 3 here from this is to increase this exponent by 1 and increase this exponent by 1. That's 1 plus 1. And multiply that. And you get 6. And in the case of 2 squared times 3 squared, oh, I'm sorry, this is 36 here. So if you want to work out the number of factors of 36, right, you'll factorize it. And then you increase the exponent of this by 1, and you increase the exponent of this by 1. The exponent here is also 2. And that is how you get 3 times 3. See? This works. The idea is to increase all the exponents by 1 and multiply them. And that will give you the total number of factors, right? So, like for instance, now suppose you want to know how many factors, this is number of factors of say 260. How many factors does 260 have? You can list the whole thing down, but if you factorize 260 into the prime powers, you will see 13 times 20 this is, and that is 13 times 4 times 5. So 260, when you write it as a product of prime powers, let's go from the smallest to the biggest. 4 is 2 squared, 5 is 5 to the 1, and 13 to the 1. I'm writing the exponents down, right? And therefore, the number of factors is now, you've got 3 prime factors, and you take each one of those, the exponent is 2, multiplied by the exponent of this is 2, so is 1 plus 1, and here you have 1 plus 1. So the number of factors of this number here is 12. If you try it out, you will see you'll get exactly 12 factors. Without actually listing the factors, you can work out the number of factors, right? Which is a very powerful, beautiful way of getting to the answer. That's the power of mathematics, without actually listing them down. Now, so in this case here, this is already factorized into prime numbers. All these are prime numbers. So you've already finished the first stage of writing it as a product of prime powers is already done for us. So we can write down the answer straight away. Somebody is writing on my... Please don't do that. I'm not sure who it is. Okay, so you increase each of these exponents by 1, and all the exponents are 1. So when you increase each of them by 1, you'll get all 2's, and the answer is 16. Okay, so that was a quick lesson into the number of factors of a given number. Okay, if you want to know more about that, and if you got my book, you can go and read the full exposition on that with many other examples. Okay, I just included that to extend your knowledge on that particular topic. Okay. So now, so remember, let me just sum up. So here's a fact. So the fact is, the number of factors of n. If you want to work out how many factors, sorry, my writing is not bad, not good at all. Factors of n is any number, right? The first step is you write n as a product of powers of prime. So you can put 2 to the power of say a, 3 to the power of b, 5 to the power of c, 7 to the power of d, and so on. Every number can be written as like this, but sometimes you may have these powers are 0. Like if 2 was not a factor, then if it's an odd number, then you'll have a equal to 0. So 2 to the 0 is 1, you see. So you allowed 0 in this form. Okay. So sometimes the exponents can be 0. So that's the first step. And then you will say the answer, the number of factors, you can write it straight away, equals a plus 1 times b plus 1. Increase all the exponents by 1 and multiply all of them together. So that's the method of doing it. Observe that if a is equal to 0, then a plus 1 is just 1. So that doesn't contribute anything. You got 1 times 1 times 1. That doesn't contribute anything to the number of factors. Okay. So it's only interesting if these powers are greater or equal to 1. If a is 0, we've got the formula, but it's not so interesting. So generally, you will say that the exponents are at least equal to 1. So that takes me to this next problem. So here now we've got an application of what we've just said. Find all numbers less than 50 that have exactly 4 factors. All right, I'm going to write down the solution here. So we don't know what the numbers are. So we'll give a name to such a number. Let n, and I'm going to write it down in the factorized form because we'll need this. 2 to the a times 3 to the b times 5 to the power of c, and so on. Be such a number. Now, that means this number has got exactly 4 factors. Okay, so what does this mean? So how many factors does n have? Then, from what we've just said, the number of factors is a plus 1 times b plus 1 times c plus 1, and so on. That's the number of factors. But we are given that the number of factors is actually equal to 4. Right? So how can that be? You got a number of positive integers whose product is 4. Right? Now, you could have, if the product is 4, it could be 4 times 1. Now, 4 times 1 or 2 times 2. Those are the only possibilities. Right? So if it's 4 times 1, then you could have that, can I have a, 4 times 1 means all of these are 1, except one of them, which is 4. Then one of the factors is 4. Let's take 4 times 1 case. And all the others are 1. Now, in the case of 1, that means that a will then be 0. Right? So you will have, so in that case, n will be equal to, it could be, for instance, you're going to have 2 cubed, because now a plus 1 is 4. Suppose a plus 1 is 4. Then a is 3. And all the others are 0. Right? Because then all these are 1, so the b equals 0. So you don't have to multiply this by 1 times 1 times 1. Okay, n is equal to, so this is the case where a equals 0. I mean, a equals 3. That'll give you that. If you have b equals 3, could have had that. Then in that case, you'll have n is equal to, all the others are 0, so you'll have b, which is 3, so you'll have 3 cubed. This b here is 3 now, and a is 0, b is 3, and all the others are 0. So you can have this, or you could have c equal to 3, but then you will have n is equal to 5 cubed, and so on. But it is given that these numbers are less than 50, so this is allowed. That's 8. This is 27. But this is greater than 50. So we don't count all the numbers, the other ones, to be equal to 3. The only ones which are admissible is either this is 3 or that is 3. The other ones give you numbers which are more than 50. Okay, so this is greater or equal to 50. So you have to eliminate them. So we can count that and that. Now, the other case, where you have 2 times 2, what does this mean? It means that A is equal to 1 and B equals 1. So you'll have that 2 of them are 2. 2 indices or exponents are 1, because this is A plus 1, B plus 1, and so on, are 1, and the others are 0. That's the only way you can have that this product is 4. Right? You have 2 of them are 2. We don't know which 2, but all the others are equal to 1, in which case all the others, the exponents are 0. All right, so what does this mean? It means you got n is equal to now just a product of 2 primes, because these 2 exponents are just, 2 of them are 1. So n is equal to, we don't know what they are. It could be 2 to the 1 times 3 to the 1, or 5 to the 1 times 7 to the 1, or 11 to the 1 times 13 to the 1. We don't know what it is. We don't know where the 2 ones are. So we can just say it's p times q, where p and q are prime numbers. We don't know which of these indices are equal to 2 in this case. So here you have that n is a product of 2 prime numbers. Now you need to work out all the products of 2 prime numbers which are less than 50. Okay, and PQ is less than 50. Okay. Now I'm not going to do it, but I'm just going to tell you how it goes. So you'll have 2 times. These are different prime numbers, right? They are different prime numbers because we wrote it down like that. So you'll have 2 times 3, 2 times 5, 2 times 7, 2 times 11, and so on, going all the way up to 2 times. You can only go up to 23 is a prime number, right? But the next prime number after 23 is 29, and that's too much. 2 times 29 is 58. So you can stop here. So you can count all these. In other words, you actually count how many primes are there less than or equal to 23. That gives you that lot. That's where you're starting with 2. But you could have started with 3, in which case you have 3 times 5, 3 times 7, 3 times, 3 times 7, 3 times 11, 3 times 13, 3 times. The next prime number after 13 is 17, and 3 times 17 is 51. So you can this only give you 4. So 15, 21, 33, 39, they're all allowed. And you can go on like that. You can, with 5, you only have 5 times 7. You don't have to go do 5 times 3 again. 5 times 7, that's all. 5 times 11 is too much. So you can count how many there are. I'm not sure exactly how many there are, but you can do it. So you can count all the numbers here. How many? There are 4 here and 1 here. So altogether, you can work out all the numbers. They don't say how, they don't ask how many numbers there are. They say write all the numbers. So you have to write down all these solutions. Okay, so that was quite a mouthful. It took a lot of time. So I want to move on to the next problem. Okay, this session will be recorded and it will be available for at least for exactly 1 week, I think. So you can go back and listen to it in case you are doubtful about something, in case you missed something, because I am going fairly briskly to try to finish all the problems that I've got. Okay, the next one. Now, what we are doing here is what you call number theory. Most of these problems are only regarding natural numbers, you'll notice. All counting numbers, right? We're talking about factorization and division and so on. Yeah, right through, the mathematics is about counting numbers. And the mathematics of counting numbers is called number theory. There's a lot of very interesting things that one can say about counting numbers. And these problems in the Olympiads deal with quite a lot of those kinds of problems, right? Where the answers are counting numbers. You're not including numbers like a half and √2 and so on. Sometimes you will have those numbers, but in many cases when there are problems involving numbers, you have counting numbers. Now in this case here, problem 4, when 2024 is divided by n, the remainder is 15. Find all possible values of n. So this is an interesting problem. So when you're dividing 2024 by n, the remainder is 15. So you're dividing it by n, and in the end you have a remainder of 15. So what does this mean? It means that when you take 15 away from 2024, then that number is an exact multiple of 15, of n. So this is a multiple. The constant remainders are very important in these problems. So here is a lesson here. I'm saying that you have to get a good understanding of what you mean by the remainder. See, generally when you have a number, say m, and you're dividing it by n, and you get a remainder, then what it means is that the remainder, when you take it away from m, you're going to get a multiple of n. Now, what do you mean by multiple? A multiple of n is an integer times n. So it's n times what we call q, because this is a quotient. Right? When you divide this, you get a quotient and a remainder. That is why I'm calling this r. So your number m minus r is a multiple of your divisor. Right? And generally you have m is equal to nq plus r, like that. But the important thing is that this remainder here must always be smaller than your divisor. You can't have a remainder bigger than whatever you're dividing by. You know that very well. When you're dividing by 4, you can't have a remainder of 5. Most people will say, oh, that's impossible. Right? And that's because the rule is that when you're working out the remainder, you want to take out as many n's from m as possible until such time you cannot take out any more. So you'll have to land up with a number which is smaller than whatever you are taking out. So this remainder is always smaller than the divisor. Okay. So this means here that your n is greater than 15. Because, as I said, the remainder is always smaller. It can't be equal to it. It must be strictly smaller. So this is what you've got. You've got 2024 minus 15 is 2009. Is a multiple of n. And n is greater than 15. Okay, so trying to understand what the problem is, we landed up by reformulating that the given information, and we see that the number that we're looking for is a factor of 2009, and it's a factor which is greater than 15. So now so the problem is to look at the factors of 2009. Okay, and again, you will try all the numbers from 2, 3, and so on, and you'll see when you come to 7, 7 goes exactly into this, 287. Now you have to factorize this, and 7 goes into that again. So you'll end up with 7 times 7 times 41. Yeah. So you go 7 squared times 41. So according to what we said earlier on, you are looking for factors of 2009, right? And those factors will have to be greater than 15. So you can list all the factors of this down. We're supposed to be having 6 factors because this is the number of factors is 3 times 2 from what we said earlier, which is 6. So you can write down all the 6 factors, but you're going to choose only those factors which are bigger than 15. So you're not allowed to choose 7, for instance. And after that, I think you have 41, 49, 287. You also have 2009. 2009 is also a factor of itself, right? So I think these will be the factors which are greater than 15. The other factor which, there are 4 here. The other 2 are 1 and 7. But they're not allowed because your divisor has to be greater than 15. Because the remainder is 15, you see. So you can't have you can't have a remainder of 15 for these values of n. Okay, so the answer is determine all possible values for n. These are the possible values. Okay. So to recap, we used what we said did earlier on, but the important thing here is that the remainder, the connection between the remainder, the divisor, these 4 numbers, whenever you're dividing, this applies only to counting numbers. You can't divide something by half and get remainders, right? You get remainders only when you're working with natural numbers, the kind of numbers you worked with in primary school. So this is all counting numbers, positive integers. And when you have a number m divided by n and the quotient is q and the remainder is r, you're going to have this important formula that m is actually equal to nq or qn plus r, because n minus r is a multiple of m, and that multiple is q. It's the largest factor of m in n. Okay, so this is an important fact, which I will just state here for the sake of completion. If the remainder is R when M is divided by N and the quotient is Q, then your M is equal to Q times N plus R. And we must remember that R must be less than N. It's extremely important. Your remainder is always smaller than your divisor, right? That's the golden rule for division. If I ask you, what is 17 divided by 3, right? You can't tell me it's 4 remainder 5, which is a possible answer. You tell me it's because 3 goes into this 4 times 12, remainder is 5. You're not allowed to do that. The remainder can't be 5, right? It has to be smaller than 3. Okay, so this whole theory of remainders is very, very important. In the book, the theory of remainders is under the subject called congruence. Now, this is not congruence in geometry, but congruence in numbers. So if you want to know more about this, you can go and read that section on congruences. And there's a very, very powerful theory around this, and it makes mathematics very easy if you understand the theory of remainders, right? So we've just got a small glimpse into remainders here, and that allowed me to give you a small discussion on how the remainders work. Okay, so the next one, okay, so now we're looking at this one. In a classed test, each learner scored 1, 4, 5, or 8. Let me just stop here. And let me welcome everybody. I'm happy to see that we've got quite a good class of 25 participants today. Some of you came in late, so let me welcome all of you. Try, please, in future to try to be on time, because in future I'm going to start almost exactly on time. And if you come a little late, you might miss the solutions to the early problems. Okay. If you have any questions, something that you didn't understand, you can write it in the chat column. Put it under chat, and if we have time at the end of the session, I will discuss those problems. But put it under chat, and hopefully your name will come up. If your name doesn't come up, just write down your name, your surname, and initial, and put down the question. And if I've already answered it, I wouldn't attend to it. But if I haven't answered it, then you can wait after the session and I can address it. But don't hesitate. Please do write down your questions in the chat column. Okay. I know that sometimes when I allowed everybody to write the chat column, some people were writing nonsense there. Please don't take the chance and write nonsense. Otherwise, we will take you out of the class. And that's not a joke. Some people write all kinds of things there, but we know who you are. So don't take any chances. Make sure you write some question, which is a legitimate question. In a class test, each learner scores 1, 4, 5, or 8 points. The number of learners who scored 4 points is the same as the number who scored 5. The total number of points scored by the class is 63 more than the number of learners in the class. How many learners scored 5 or more points? Now, once again, this is a what we call a word problem, and it's quite a mouthful. You can't absorb all this simultaneously. It's too much, right? But the gist of it is that you've got 4 numbers which are possible scores. So let's just write them down here. You can get a score of 1, 4, 5, or 8. Now, the number of learners who scored 4 points. So now you're talking about the number of learners who scored different points here. So we don't know what these are, right? So let's just give a name to the number of learners who scored these points. Now you could get quite a few unknowns here because we don't know how many scored 1, 8. So we'll give names A, B, C, D. So when you see B, you must know it is the number of learners who scored 4 points. All right. So now you've got 4 unknowns here. And you've hardly ever did problems with 4 unknowns. But let's take a deep breath and try to see what we can make of this. The number of learners who scored 4 points is the same as the number who scored 5. So the number of learners who scored 4 points is B, and it's the same as this. So I'm not going to write down C here because I can get rid of that unknown. That is the same as that. So I can call that B as well. So now instead of 4 unknowns, I've got 3 unknowns. So I've used this information here. It's used. The total number of points scored by the class is 63 more than the number of learners in the class. Now that needs to be translated. The total number of points. Let's work out the total number of points scored. We need to know that number, right? So, well, there were A people who scored 1 point. So there were 8 points. The B people scored 4 points. Each of them scored 4 points. So altogether, they scored 4 B points. So that gives you the number of people who scored 1 point or 4 points. And likewise, those people who scored 5 points, that gives you 5B and 8D. I'm adding all this because I'm working out the total number of points scored. So you got the number of people who scored, the total number of points that 1 contributes, that 4 contributes, 5 contributes, and 8 contributes. So that gives you the total number of points. And this can be simplified because the B's are here. A+, we've got that. Now this is 63 more than the number of learners in the class. So let's just look at the number of learners. What is that? Well, that's easy because you've got all these learners here. A plus, I can put down B plus B. I'll write down 2B straight away. Plus D. This is the number of learners. Okay, so now you are told that this number here is 63 more than this. So this number is 63 more than this. So when I add 63 to this, I'm going to get that. Okay, so this the information that we are given, we eventually came to this. And now, how many learners scored 5 or more points? Now, let's have a look at that. The number of learners who scored 5 points is B, and the number of learners who scored, the only 2 numbers which you can get more than 5 points, who scored 5 points, together with the total number of people who scored 8 points, is B plus D. So that is your question. You're not asked to work out A, B, and D separately. The question is, how many people who scored 5 or more points? So that is what, it's very important to read the question. Otherwise, you'll think you need to calculate all these numbers. You need not calculate the numbers. You only need to know what B plus D is. So now we've got all the information and we've got that down into an equation. So let's A and the A on both sides, we can cancel that off. You got 2B. Let's bring the B's. 2B minus 9B plus D minus 8D, bring it to the other side, is minus 63. All right, so if you bring the A's cancel and you bring all the B's to one side, you have that. And let me just create some space here. Don't need this anymore. Now, 2B minus 9B is minus 7B. D minus 8D is minus 8D, minus 7D. And that is negative 63. Oh, 7 goes into all these. So, negative 7. So, it will be divided by negative 7. And lo and behold, we have the answer to the problem. It just suddenly melts into view. And by taking your information down, putting them together, getting an equation, right? Goal in problem solving, you put in symbols and get equations to solve for your symbols. Well, I've got those 4 symbols and I eventually came to an equation. And then having solved that equation, I cannot solve it, but I can get B plus D. But that is exactly what they asked. So the answer is the number of people who scored 5 points or more is 9. Okay, so we go on to the next problem. Again, you have a problem involving positive integers. So we've had a lot of problems involving integers because this is the section here, session 2, I've dedicated it to problems involving integers. So that is why all your symbols here are all integers. But each time the question tells you that they are integers or positive integers. In this case, in this particular problem here, A, B, and C are positive integers. And you have the rather complicated equation here. And find all the solution sets for A, B, and C. Now, these are integers now. You got one equation with 3 unknowns. The only thing we know about them are they are positive integers. So it requires quite a lot of skill to actually solve this. So when it comes to these integers, what you try to do is to sort of zone in on what the possible things are, the observations you can make from this equation. All right. Now, let me deal with only 2 of these unknowns, 28a plus 30b equals 365 minus 31c. Now, all we know is that a is a positive integer. So a and b and c are all greater or equal to 1. Right? They're integers, 1, 2, 3, 4, 5, and they're positive. So we know that a is greater or equal to 1. So you got 28b. Let's put it down like this: 365 minus 31c. I'll put it down like this: 28a plus 30b. So a is greater or equal to 1. So make this 28a will be greater or equal to 28 because a is greater or equal to 1. The same with 30b, that's greater or equal to 30 because b is greater or equal to 1. So you have 58 here. So now you have only one unknown, but it's an inequality. I've sort of knocked out a and b by saying it's larger than a given integer. So what do you have? You have this equation, 365 minus 31c is greater or equal to 58. Could be equal because a could be equal to 1 and b could be equal to 1. Okay, so let's just make 31c your subject. 31c, if you bring it to that side, that will be less than or equal to 365 minus 58, and that is 307. So 31c is less than or equal to that. So c is less than or equal to 307 over 31. You're not allowed to use calculators. But if you try to see what this number is, it's like it's actually 9. 31 times 9 is 279, and 28 over 31. Okay, so you get the c is less than or equal to this, but c is a positive integer. So c is equal to 1, 2, 3, 4, 5, 6, 7, 8, or 9. Now, I want you to notice something else. You see, let's have a look at this equation here. 28a plus 30b equals 365 minus 31c. An important observation here is that the left-hand side is even, right? Because 2 is a factor of this. So therefore, this is even. Now, you want this quantity here to be even. That tells you something about C. If 365 minus 31C is even, it means 31C is 365 minus an even number. But 365 minus even number is an odd number. When you take out an even number from an odd number, you land up with an odd number. These are important facts to remember about positive integers. You already know it, but they are exploited several times. When you add two even numbers, you get even numbers. When you add two odd numbers, you get an even number. So you have to know all those at your fingertips. So if you got an odd number minus an even number, that number has to be odd. But if 31 times C is an odd number, that makes C odd. See? So therefore, we can eliminate all the even numbers here, and you can say C is equal to 1 or 3 or 5 or 7 or 9. So there are several possibilities for C. 5 possibilities, but at least we brought it down to only 5 possibilities for C. Okay, so that long discussion allowed me to say something about C. So let's go back to what we had in the beginning and give these possible values for C. I need space, so I'm going to wipe out all these things. And just record my conclusion. C is 1, 3, 5, 7, or 9. Now I'm going to go back to 28A plus 30B is equal to 365 minus 31C. And I'm going to substitute these different values for C. C equal to 1 gives you 334. You don't need calculators for this. You can work it out. 365 minus 31C. C equals 1. C equals 3. This is 93. So you get 272. You can do it on a page. I can do it mentally. When I'm subtracting 93 from this, when I put C equal to 5, I got 31 times 5, which is 155. And when you take out 155 from that, you got 210. And when C is equal to 7, you got 217. And 365 minus 217 is 148. And then when C is equal to 9, you have 279, and that gives you 86. Okay, you must just don't get get all stressed by this. These are little calculations. I'm putting different values for C. Now I want to work out in each of these cases. I want to see whether you got a solution. 28A plus 30B equals 334. Right? Now it's a long process, but we want to another way of looking at it is 28A equals 334 minus 30B. So you look at the multiples of 30, subtract it from this, and see whether any one of them is a multiple of 28. Because these are all multiples, these are all positive integers, right? So when you try them out, so 60, 90, 120. I don't think you have any solutions for this. Right? You can try out all the values for B, different values for B, right? And you'll see that none of these values for B gives you a multiple of 28. Right. Now you can do the same thing for 272 and for this. All right. But I'll just go to 28A plus 30B equals 86. Right? And I see that when B is equal to 2, or B is equal to 1, you have 28A equals 86 minus 30, which is 56. And that is a multiple of 28. So A equals 2. So you do have B equals 1, A equals to 2, and now then you can calculate what C is, because this was at the last one, C is equal to 9. When you try C equals 9, then you have this equation. So this gives you a solution. And we normally write down the solution as A, B, C, like that, put it in round brackets, separated by commas, and you have it's 2, A equals 2, B equals 1, C equals 9. So you get finally you get an equation with two unknowns, and it's by trial and error you see what the solutions are. All right. Now, and then you can try the other ones. Okay, but I'm going to tell you something else here. We found one solution. We don't know whether there are any other solutions. But Mr. Wise Guy will say the following. He wouldn't go blindly into this problem. He will say, hey, these numbers are very familiar. 365 is not a random number, guy. Right. 28 and 30 and 31, they are not random numbers. There's something about them. Namely, this is the number of days in the year. 365. This is the number of months, which has 28. There's only one month which will have 28 in a leap year. I mean, it's a non-leap year. And how many months have 30 days? 30 days at September, April, June, and November. So 30 days at September, April, June. So B is equal to 4. There are 4 months which have 30 days, and the remaining ones, that's 7 months, have 31 days. So you've got 31 days which have 7 months which have got 31 days, 4. So another solution is A equals 1, 4, and 7. But this is the solution for C equal to 7. See this one here? It came to 148. Right? So here you would have had 28A plus 30B equals 148. That would have given me a solution for C equal to 7. And our solution would have been B equals 4. So 4 times 30 is 120. 28A plus 120 equals 148. And lo and behold, 148 minus 120 is 28, which is a multiple, and A equals 1. So this one here, if we plotted along, we would have got this, will also given a solution. So there are 2 solutions, and one is, so Mr. Wise Guy would have given this thing and said, "Ah, this is an easy problem, man. This is," but he would have given that solution, but he would not have given that solution. So he is really a wise guy who is not so wise, right? Um, but if I was marking him and and if the marks were 10, I would give him 6 or 7 for the insight, for recognizing that this problem here is a real world problem and you can solve it using real world facts, right? Which is intuitively very strong. And although the rest of the calculations are quite complicated, but maybe I might not have given him so many, but be that as it may, I would have been very appreciative of that solution. Now, this one here is marked in red. And the reason I marked in red, as I did last week, those of you were here last week, is that this is your homework problem. Your assignment problem is number 10 of session 2, quite early here. So you have to go and battle it out with that problem, and hopefully you'll get the answer to that problem. Okay, so we go on to, obviously I'm not going to work that out. It's your business. Okay, the next problem says Kevin received a 100 Rand gift voucher to be spent at a store. He aims to purchase 20 items using all the money. The items he's interested in are pens, which are 5 Rands each, notebooks, 7 Rands each, rubbers, 2 Rands each. This in the form of pens, notebooks, rubbers, all the different ways he can spend all his money. He must spend all his money, but he buys at least one of each of the 3 items. Okay, again, now this is a mouthful, and like a previous one, the unknowns here are how many pens, how many notebooks, and how many rubbers does he buy. So I'm going to use symbols for these pens, notebooks, rubbers. But just to keep track, I'm going to call them P for pens, N for notebooks, R for rubbers. You can call it X, Y, Z, A, B, C, whatever. But I like using symbols which so that I can keep track of what the symbols mean. Each time I got a symbol, I want to know exactly what it means. In mathematics, you have to know, if you're using symbols, you must know exactly what it means so that you can take the context and make equations out of them. All right, so bearing that in mind, he receives a 100 Rand gift voucher. So his spending will be 100 Rands, but he buys 20 items. So, and he says, he buys at least one of each of the 3 items. So it means that P and N and R are all each greater or equal to 1. None of them is 0, right? And they are all together, they sum to 20. So we can put P plus N plus R equals 20. So that first one says he purchased 20 items. So if he's putting P pens, N notebooks, and R rubbers, all together you would have purchased P plus N plus R items, and that is equal to 20. So that's your first equation. Now the second one is about costs. The pens cost 5 Rands each. The notebooks cost 7 Rands each. And the rubbers cost 2 Rands each. Right? So each pen is 5 Rands, each notebook is 7 Rands, each rubber is 2 Rands. So now you can actually calculate how much he spends. And it says here that he spent all his money. The whole, all the 100 Rands that he had. So in other words, now, let me see how much he spent altogether. He would have spent, each pen costs 5 Rands. So he bought P pens. So he would have spent so much on pens, 5 times P. And he would have spent 7 times N on notebooks. Together he would have spent so much. And then on the rubbers, it's 2R. So the total amount of money he spent was 5P plus 7N plus 2R, and that is 100. Okay, now this is better than the previous problem or an earlier problem. Actually, it's the last problem where you got two equations. The other one we only had one equation, but somehow we managed to get two solutions for it. But here you got two equations. Okay, so the question is now, it seems that there is a unique solution for this thing because it says, oh no, all the different ways. So there's probably more than one answer. So let's have a look at this thing. We've got two equations with three unknowns. How do you solve these? Whenever you got equations with unknowns, the nicest way of doing it is to eliminate some unknown. Like for instance, when you got 2x plus 3y equals 5 and minus 4x plus 7y equals 10. So you eliminate x's. And the way to eliminate x's, you multiply this by something so that you make these two the same, and then you add or subtract so that that guy disappears. And the only survivors are the one remaining ones. So I'm going to do the same thing here. I have to multiply this by something to eliminate and then subtract or add. But before we jump into this thing here, I see that 20 is 5 times 100 and P, and I've got 5P here. So why don't I multiply the first one by 5? Multiply the first equation by 5. Then you get 5P plus 5N plus 5R equals 100. Right? And the nice thing here is when you subtract now, that goes away. 7N minus 5N is 2N. 2R minus 5R is 3R. 100 minus R, 100 is 0. Right. So that's very nice. Now you got one equation with two unknowns, but the interesting thing about this, let's just don't keep them all on one side. Oh. Yeah, if you put it like this, 2N equals 3R, the reason why I want to do this is that I want to give different values for R, right? So different values of R will give you different values for N. Then I can solve for N and R. Okay, so let's give different values for R. So put R equals 1. Put R equals 1. You have 2N equals 3. N equals 3 over 2. Now that's not allowed. It's not allowed because these are all counting numbers here. You can't buy 1.5 notebooks. 3 over 2 is 1.5. You're not allowed to do this. So R equals 1 does not give you a solution. But you'll notice here that actually 2N equals 3R. It means that this thing here is even because 2N is even, right? So if 3 times R is even, just like what we did earlier on, if 3 times R is even, that forces R to be even. You don't want, if R is odd, now that is why it didn't work here. So you need to make values for R. They have to be even numbers. So you make R equal to 2 or 4 or 6 or 8, 10, 12, and so on. So these are the possible values for R. And then once you do that, then N is equal to, if R is 2, then 2N is equal to 6. So N is 3. If R is equal to 4, you have 3 times 4 is 12. 2N is 12. 6. You actually have 3, 6, 9, 12, 15, 18, like that. You have all these multiples of 3 when you try it out. See? Or if you like, we can actually say, given R, we can calculate n to be 3R over 2. So you can put 3 times R over 2 like that. See? So it's 3 times half R. So this is 3 times half R, which is 3 times 1. This is 3 times half 4, which is 6. 3 times half 6, which is 9. So if you rewrite it like this, you can see why it's a multiple of 3. If R is even, this becomes a whole number here. You divide by 2. Okay, so you got n and R, the possible values for n and R. And then P, well, when you add all of them, you're going to get 20. So here, 2 plus 3 is 5, so you got 15. 4 plus 6 is 10. You're going to add the 3 numbers, you got 20. 6 plus 9 is 15. So you must have 5 here. 8 plus 12 is 20. That gives you 0. 10 plus 15 is 25. So you have to get 20, you get negative 5. So now these are not allowed. You're not allowed to get P equal to, because P is greater or equal to 1, you see. So you're not allowed to get P equal to 0. So all these are out. So these are the only 3 possible values for P. So now as you run R through the different even numbers, you get different values for N, different values for P. But if you want to put them together now, then you can see there are only 3 solutions for this. 3. I'm going to write down the solutions. So P N R equals, right, P is 15. You have to go backwards. 15 N 2. So that is a possible value for P N and R. Here you have 1064. And here you have 569, 596. And those are the only solutions, because these values of P do not admit solutions. So you see, you can actually solve this using mathematics. To solve this problem here, you actually can solve them without having to guess. Otherwise, if you didn't know all this, you'll try to guess now. Okay, suppose you got 6 notebooks and five rubbers, and you can spend a whole lot of time trying to, get the answers. And even then, too, you might get 1 or 2 answers, and you might not get, all the answers. Now, this method here gives you all the answers. So this is the power of algebra. This is a great thing about algebra. You see? So, and you can see you're using your normal school algebra here. Got 3 equations with 2 unknowns. Eliminate one of those unknowns, and then continue. Don't give up. You see, remember, these are counting numbers. So that's very powerful, which means that you can say that 2n is even. Now, you can't generally say 2n is even. Be careful. Sometimes you might say, if I ask you, is this number even? You might say, yes, it is. Then I'll say, no, it's not even, because 2 times half is not even. See, you have to say that n is a counting number, then only this is even. And you're not allowed to use fractions. So we already know that they are counting numbers, so that's fine. The other way you could have done this, you could have said that n is a multiple of 3. You see, because n is a factor of that, is also a factor of 3r. Right? So, put it this way, 3 is a factor of 2n. So 3 is a factor of 2 times something, so that n has to be a multiple of 3. You could have done it that way as well. And we saw n is a multiple of 3. You could have started there and get the values for r and so on, and get to the final answers. Okay, so we've come to this one here now. Jack and Jill have a number of 50-cent and 20-cent coins. Jack has P more 20-cent coins than Jill. A 50-cent coin is Q grams heavier than a 20-cent coin. Both have the same number of coins altogether. Who has more money and by how much? This is quite a mouthful of a problem. It looks as if it's very, very difficult to solve. And as a matter of fact, it is a little bit tricky. But let's look at it again the way I do it, systematically. Right? Now, the point is, each of them have got a number of these coins, so we don't know how many of each coin we have. So there are two people, so let's just draw a little grid here to separate Jack and Jill. Because you're talking about 20-cent coins and 50-cent coins. Right, now we don't know Jack. In these boxes here, we'll put A and B, which means Jack has A 20-cent coins and B 50-cent coins. Right, we don't know how many. And the same thing with Jill, we don't know in her case, and it's got nothing to do with what Jack has got. So we have to put C and D's. So you've got 4 unknowns here. The number of 20-cent coins that each of them has, the number of 50-cent coins each of them has. Now that we've got symbols, we can translate the given information into equations. All right. Jack has P more 20-cent coins than Jill. Right. So it means that Jack has more coins than Jill, and A, that's Jack's, the number of 20-cent coins Jack has is A, right? And then he's got P more coins than Jill, 20-cent coins. Jill has got C 20-cent coins. Jack has got A 20-cent coins. And A is P more than C. So I'm translating all this into that. Okay. Now I want to answer the first question first, because then after that you got a question on weights, grams, and so on. So let's ignore that, because the second part is on weights. Let's just look at the first part. How much? Who has more money and by how much? But we have a third piece of information here. I'm ignoring this one here for the time being. I just want to talk about the amount of money they've got. Both have the same number of coins altogether. Right. So how many coins does Jack have? Jack has got A plus B coins. Right? Because he's got A20, and Jill has got C plus D. They got the same number of coins. So the total number of coins that Jack has is equal to the total number of coins that Jill has. So from here now you can say that A minus C is equal to D minus B. Why do I say that? Because I know that A minus C is equal to P from here, right? So you got A minus C equals D minus B. So the first part is how much more money and by how much? Who has more money? All right, let's see now. Jack has got B 50-cent coins. Jill has got D 50-cent coins. I'm going to subtract Jack's money minus Jill's money. I want to see how much more. The question is how much more money. So to do that, you have to subtract the two, and we need to get to that answer. So Jack's money, he's got B 50-cent coins, and Jill has got D 50-cent coins. So therefore, Jack will have 50 times B minus D more. This may be negative. We don't know what it is, but it could have less or more. But B minus D, we were talking about Jack's money minus Jill's money. And then, as far as the 20-cent coins is concerned, Jack has got A minus C times 20. Now this is the difference between the two, right? Because he's got A minus C more coins. So so that'll be 20 into that. Now we just said that A minus C equals D minus B. So this is minus 50p. The b minus d is equal, d minus b is equal to p. So if you turn it around, you're going to get minus plus 20, and a minus c is p. So this is minus 30p. So Jack's money minus Jill's money is minus 30p, so which means that Jack has got less money because it's negative. So Jill has more money. And the actual difference is by 30p. P is given. We are told that Jack has got p coins more than that. So the A and the B and the C all that disappeared in this answer here. See, it's quite remarkable question, the way the question is phrased. So you can answer this question. In the same way you can answer this other question. If the total mass of Jill's coins is S grams, what is the total mass of Jack's coins? Okay. This is a little bit more complicated, but I'm going to, okay, now I want to keep this equation. Now we're going to talk about weights, masses. Okay, let's do it systematically. The total mass of Jill's coins. Now, what is the total? Oh, okay, now we need to know what the weight of a 20-cent coin is and what the weight of a 50-cent coin is. So suppose we say let X equal to the weight of a 20-cent coin and Y the weight of a 50-cent coin, right? It's given here that the 50-cent coin is Q grams heavier than a 20. So you got Y minus X is actually equal to Q, because the weight of the 50-cent coin is Q grams more than that. So there it is. You got an equation here. Then the second piece of information that is given is, which we ignored before. Now we're going to look at it. A 50-cent coin. Okay. The total mass of Jill's coins is S grams. So what is the total mass of coins? Mass of Jill's coins. Total mass. Okay, let's see. Let's weigh all Jill's coins. She's got C 20 coins, 20-cent coins. Each of the 20 cents weighs X. We said that. So the weight of the 20-cent coins will be CX. And likewise, the weight of the 50-cent coins will be DY. And the total weight of Jill's coins is CX plus DY, and that is S. Right? Now, the question is, what is the total mass of Jack's coins? Right? So again, as we said before, we'll work out Jack's mass minus Jill's mass. Total mass. That will be equal to, what is the total mass of Jack's coins? It's going to be AX plus BY minus CX plus DY. Now we actually have to put CX plus DY. We're not going to substitute S here straight away. It's this is equal to S here. So Jack's mass minus S is equal to this, and I'm going to substitute CX plus DY here. Calculate this. X into A minus C X is a common factor, and plus Y into B minus D. Sorry, I'm going a little bit overboard here. So you have A minus A minus C is minus P. This is minus P. So this is minus PX. See, A minus C is P. Okay, it's PX. And B minus D is minus P. So it's minus YP. Because B minus D is minus, but now P comes out as a common factor. Now, Y minus X is Q. So this is minus PQ. Because Y minus X is Q. So you got Jack's mass minus S is equal to minus Q, P. So Jack's mass, if you bring the S to the other side, is S minus PQ. These are given numbers. S is given, P and Q are given. So given those two, you can actually calculate Jack's mass. Okay, this is rather complicated. It's all equations and writing down the equations and trying to solve them. But the important thing is, what is the question? The question, who has more money and by how much? So to calculate who has more money, you have to subtract the two quantities. And that is the crucial part. The same thing with weight. You have to subtract the two weights and then put the mathematics into it, substitute the equations, look at whatever equations you have written down, and somehow get to the answer. Okay. Now, I have to stop there. Although I've got one more question. I don't think I've got time for that question, which I was supposed to do. So we're gonna stop right there because we've already exceeded our time by 4 minutes. Okay. Now we have come to the end of the lesson class, and we have a couple of questions on chat here. Let me. So somebody. Oh, okay. Today's session is being recorded and will be available on YouTube from tomorrow. Okay. My the assistant, Akhiso, has written this down here. Here is a YouTube link.
Yes, Prof.
Okay, so you talk to them.
Oh yes, I was saying that the today's session will be on YouTube. Then I've also posted a link in chat that they can follow.
All right. So
Yes.
so okay. All right. Yeah, that should be okay. This link here now, how do they copy the link from here into the telephone? Okay, so you got it here on the chat call. Okay, so
Prof, I was thinking that they can follow the link and subscribe to the SA Mathematics Foundation YouTube channel. That way they can always be able to find your videos.
Okay. So once you get into the guys, SAMF YouTube channel, SAMF is www. I don't know whether you've got that. Just write this thing down in case you don't have that. Okay, so we can't assume that everybody knows SAMF YouTube channel.
Okay.
www.samf.ac.za.
Yes.
Write this down. And then once you get into the web page of the South African Maths Foundation, and somehow get into the YouTube, I'm not sure how it's done, and then look for the link. Have you got it listed nicely? Let's see how you named it. You named it in this way here. How do they know it's a senior, second round?
Oh, Prof, the videos, they have titles.
Oh,
like they'll be able to read. Yes.
Okay, so they'll be able to access it without any further information. Huh?
Yes.
Because they have to look for the section 2 of the senior. And,
Yes,
and
it's
you will
written
have it
session
named.
2.
Yeah, you'll have it named on that channel.
Yes.
Okay. So you can go straight to session 2 of senior, and you can copy the link, and you will have the entire video.
Yes.
Okay. Thank you. Thank you very much, guys. Kagi, so just stay behind. I just need to talk to you about one thing.
Okay.
I see we've got 17 participants, so 8 people have moved on. So guys, you can leave the classroom now. Thank you very much for attending. Okay. Thanks. Am I seeing David?
Yes, Prof. I'm here.
Oh, okay. I thought I was speaking to Kakiso. I can't see him. He's under the SAMF lot.
Yes,
Yes,
I'm available. Let me try to, yes.
Oh, there you are. Okay.
Yeah.
Yeah. This you sent me the recording of the first one. It all looked quite nice. There's just one thing. I was mentioning this to David because the AI it can translate certain things, but certain mathematical things it gets a little bit confused. Because when I got the recording of the meeting, you remember, when we had a meeting, that the recording of that meeting, some of it didn't make any sense because I was talking about certain things mathematical and it didn't understand what I was saying. So just be a little bit careful when we are recording using AI recording. I was telling David that it's far better to have a sort of naked recording so that they will know. Do you understand what I'm saying? Without letting AI do the recording. Are you following me, Khagiso?
Yes, I am.
Yeah.
But then with the AI, we can also like edit the notes.
Yeah, all right. Okay. As long as you edit it and then put it up, then it's fine. Otherwise, there will be some parts of it which may be a little bit garbled. But just check it out.
Okay.
But it means now you have to listen to 1.5 hours of talks. But generally, if you just record it exactly as it is, then you can put it up because it'll give you the
I know.
message as I speak.
We're going to use only the videos, Prof, not the notes.
Okay.
Yeah,
okay, very good.
the notes is for the meeting, but this one is a class, it's not a meeting.
Okay.
Yeah, we're going to use only the videos like the ones that you already have.
Okay.
Yeah.
Okay. All right, good. That was my only concern. And
Okay.
Yes, Prof.
I'm still looking for the lists. The class list for last week, we had 2. So I don't know the names of any of the students. I don't know what their email addresses are. The Limpopo, what is the position of the Limpopo?
I'm busy with that, Prof, that list, but I created a Google form where the learners need to join only for Limpopo because we didn't have the list since last week, but now I'm having few learners. I'm pushing that so that I can have a complete list. And then I will share with you.
Excellent. And please don't share it on Google platform and Google Drive and other. I don't know all that. You just email it to me.
I can just, I will download and email it to you.
Okay.
Yes.
All right. Yeah, just send it directly to me. I'm an old-fashioned guy. I still believe in Excel.
Yes, I will do that. I'm busy with that. As I said last week, I'm busy with Limpopo. I will be assisting them with so many things. And then once everything is okay, I will send you the list. But it won't take long. Maybe
Yeah.
this week, maybe next week, everything will be okay.
Yeah. And
Yeah.
the marking of that, and I also like to have an idea of how they are doing in the assignments. So I don't know. I think
Yes.
those marks also come onto the.
No, no, I will
database.
I will discuss everything with them, and then we'll see the best way to do that. And then also we should have the mark sheet, remember, from
Yeah.
Limpopo also. And then
Yeah.
I will see, but the whole of this week I will be busy trying to get clarity and advices, and I will advise them on some of the things how we do them.
Okay. Okay.
Yeah.
Thanks. I think you are on top of things. Yeah. But
Yes.
as long as I get my class list and how they are doing, then I know from my side, I'll have some idea as to what progress we are making.
No, I already have the list. Learners are
Yeah.
busy joining, and then once it's complete, I will create the mark sheet also from that list. So, and then share with the Limpopo organizer.
Okay. Okay.
Yeah.
Very good.
Yes.
Thanks so much. And
Thank
some of the things that I've told them that they must do, the things in advance and so on, they will have all that information, I presume, because I had given instructions to learners and also to tutors. So
Okay.
yeah. So all learners must get that, so they will know what the rules are and have some idea as to what this program is all about. Okay, thank you so much. Okay, Kagiso, do you have any comments to make?
No, Prof.
Okay.
Okay.
Thanks very much to both of you for attending.
Thank you.
And
Thank you,
making my
Prof.
life a little bit easy. Okay then.
Bye.
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 Mm.